Hello, welcome back, Algebra 2. Today we're looking at the section 5.6, Fundamental Theorem of Algebra. Our goal today is to use the fundamental theorem of algebra to solve polynomial equations with complex and real roots. First, our new concept of the day, the fundamental theorem of algebra. Finally, right? We have any polynomial with degree n will have n roots, real roots, and complex roots combined. So basically, the degree of our polynomial determines the number of roots that we are going to have, whether they're real, complex, and any multiplicity of those real roots. Some things to consider are what we talked about in section 5.5, which is the conjugate root theorem, where our complex roots are going to come in conjugate pairs. So as we start investigating this, depending on whether our polynomial is an even degree or odd degree, we can start to kind of determine how many of those complex root pairs we have and then how many of those real root pairs we have. Some skills we'll need for this lesson will be the synthetic division from section 5.4, and then also finding zeros on our calculator. So those are two skills that we've been practicing that we will use in section 5.6. As we look at our first problem, we're going to find all the complex roots of x to the fifth minus x to the fourth minus 7x to the third plus 7x squared minus 18x plus 18 equals 0. Now I know that complex roots are going to come in pairs based on section 5.5. So I could have a set of 2 complex roots here, or I could have 4 complex roots. I can never have odd complex roots. So I either have 2 of them or I have 4 of them, which means I am going to have 1 or 3 real roots. So these are things you're starting to think about before you start to look at this problem. Now to find the complex roots, we are going to first find the real roots, and then we can start to use synthetic division to factor our polynomial. So the next thing I'm going to do is I'm going to put that polynomial into my calculator. So right now you can pause the video and you can put that in, and the next time you see me, I will have this in my calculator. So here I am, I've got the polynomial put into my y equals, and I'm going to double, even triple check this to make sure all of my terms are correct. These problems are set up to solve out into nice, easy roots, so I want to make sure that that's all typed in correctly. All right, once you have that in, you can hit graph, and we should start to see the real roots. Remember, the real roots are the roots that cross your x-axis. So here we go. We have 1, 2, 3 real roots. Now, if you remember back to what I was talking about, that the complex roots come in pairs, that means that we were going to have an odd number of real roots, which we do. We have a real root of -3, a real root of 1, and a real root of 3. Now that does mean that we have factors of linear factors of x plus 3, x minus 1, x minus 3, and we are going to divide those out. And to do that, we are going to use synthetic division. To divide out that linear factor of x plus 3, I'm going to use synthetic division. Now when I divide that out, I am going to use my skills from section 5.4 using synthetic division. Then we should get that remainder of 0. We talked about the remainder theorem in section 5.4. If you get a remainder of 0, that means that -3 is in fact a factor of your polynomial, which means that x plus 3 is a linear factor. Now once I get that first real root factored out, I'm going to stack my synthetic division. I'm going to divide out the next root, which is 1. Now I'm going to do my synthetic process again. And lastly, I'll do my synthetic division a third time with the root of 3. As we're dividing out these linear factors, our polynomial degree keeps getting lowered by 1. So I started out with an x to the fifth. I divided out -3. I get down to an x to the fourth. I divide out the 1. Now I'm going to divide out the 3, which is going to bring us down to an x squared, which is a quadratic, which going back to chapter 4, we have many methods to solve out that quadratic. So lastly, now I'm down to that quadratic, which ends up being x squared plus 2. Since the 0 is in that linear term, there is no x term, so I just have x squared plus 2. So now to recap, I've got down to my quadratic. I found the 3 real roots in my calculator. That means that there's 2 complex roots. Here I just have an x squared, so I can solve by subtracting 2 on both sides. I get x squared is going to equal -2. Square root, x is going to equal plus or minus. Square root of -1 is I, but root of 2 I can't simplify any further. So my 2 complex roots are plus or minus I roots of 2. So starting out, we figured out we have 5 total roots. Once we graph it, 3 of them are real, which now determines that there are going to be 2 complex roots. So remember that your complex imaginary roots are always going to come in pairs. So you're always going to have an even amount of those complex roots if you even have them. We'll take a look at problem 2. So what are the zeros of x to the 4th plus 2x to the 3rd minus 4x squared minus 7x minus 2? First thing you're going to do is put this into your calculator. Now just kind of thinking ahead, our complex roots come in pairs, so we either have 2 complex roots here or 4 complex roots, or we could have all 4 be real roots. So just kind of thinking about what we may see as we move forward here. And in this problem, we are going to look for all the zeros. In the last problem, we technically did find all the zeros, but our 2 complex roots we found at the end there. But here we will find all 4 of those roots. So let's graph it. Go ahead and type that in. You can pause the video here. Next time you see me, I'll have that typed into the calculator. All right, we got it typed in. I'm going to double, triple check. Looks like everything checks out. We hit graph. And we take a look. So we have 4 roots. We just need to know what kind of roots we have. It looks like we have 1 real root there. We have another real root there, another real root there, and another real root. So we have 1, 2, 3, 4 total roots. And we can go to our table. If you aren't quite sure where it's crossing the x-axis, you can go to where your y is equal to 0. Looks like we're going to have a real root at -1. We're also going to have a real root at 2. So we're going to use those to start our synthetic division. So we'll put our root of -1. Remember, this is the linear factor x plus 1 that we are dividing into our polynomial. So there we've divided out our 2 roots, and each time we divide out our roots, we are lowering a degree because we're factoring out an x plus 1, we're factoring out an x minus 2, and now we're down to an x squared. So here is my remaining polynomial, x squared plus 3x plus 1. I would take a second to look to see if I can factor that. There's no numbers that multiply to 1, add to 3. Can't do it, so we move on to our next method, which is going to be the quadratic formula. So next time you see me on the screen, I'm going to have my quadratic formula set up, and we are going to solve using the quadratic formula. So we've got our quadratic formula. We can take our a of 1, b of 3, and c of 1 and start to plug in our a, b, and c. So we get opposite of b, so -3 plus or minus 3 squared, which is 9, minus 4 times 1 times 1, which is 4, over 2 times 1. So I just take that 9 minus 4, that makes the discriminant underneath my radical 5. Now I'm left with -3 plus or minus the root of 5 over 2. And anytime we have this setup where we have 2 terms being added or subtracted over a single denominator, we can rewrite that as 2 separate fractions. So we're going to take -3/2 plus or minus the square root of 5 over 2. And there would be my other 2 remaining roots. So all 4 are real roots. There's no I in any of this, so we have all 4 real roots. We can also see that on our graph over here. So technically our final answer then is the roots of -1, 2, and -3/2 plus or minus the root of 5 over 2. So there are all 4 of those real roots. There they would be. So from there, we've got all 4 roots accounted for since it's a degree 4. So we are completing lesson 5.6. You're ready to start the practice. You can go ahead and get started with that. Good luck, and we'll see you next time.